Okay, somebody asked regarding that CNC machining and programming methods. So just trying to say that actually CNC machine and programming, it is not included in this course in advanced machining process. But our courses I have included. Okay, course syllabus I have included. So mostly it is non-traditional machining process. Okay, CNC machining and programming is not included here. Okay, good afternoon. Eddy current loss in ultrasonic machining process, somebody asked. Okay, so in ultrasonic machining process, actually there is a magnetostrictive type transducer it is used. Okay, so where a coil is there actually. So an electrical coil is there. In that actually magnetostrictive type transducer, whenever through a coil actually some current is flowing, so there is a eddy current actually generated. So because of that eddy current, so it generates lots of heat inside that coil. Okay, so that's why whenever there is an electromagnet is there. Okay, uh, so there is a coil is there, and inside that coil one phenomenon material is there. Okay, so which actually vibrates in case of magnetostrictive type transducer. So because of this eddy current which is generated in that coils, so this coil actually heats up. So you need to have one cooling cooling media. So that's why actually through a copper coil which is wrapped, one copper coil which is wrapped over the electromagnet. Okay, so electromagnet coil, and it through that copper channel, cold water is flown and it cools down that electromagnet. Okay, so it cools down the copper coil of that electromagnet. So in that way, that efficiency of the transducer can be maintained. Okay, nodal point clamping in ultrasonic machine. Are you talking about that clamping of that workpiece? What do you mean by this nodal point? You may ask something which is not understood, which you did not understand while going through my video and PPT. I think I have shared the PPT. So you are telling that actually clamping of that workpiece. So clamping workpiece, there is a special fixture is actually which is maintained to fix the workpiece. So in ultrasonic machining process, some delicate parts also like thin glass that is also actually can be machined. So you can make a small holes in that in a delicate parts like glasses, quartz. So in that case, actually clamping of that work is very important. So you have to design the workpiece fixture in such way that so it should not break the intricate parts. So it did not register. So you have to contact NPTEL, IIT Chennai, uh, and they will help you. So there is no access or nothing can be done from my side. So NPTEL Chennai can help you if you are not registered. Just contact them and they will help you. So in ultrasonic machining process, how high amplitude can be attained at tool? Okay, so I told that actually there are two types of transducer is used. Okay, so in that transducer, one is magnetostrictive type transducer, another one is the piezoelectric type transducer. Okay. So now in the transducer, if we apply more current, then amplitude, obviously amplitude will be increased. Otherwise, there is a horn. You might have heard that word, horn. One horn actually can be attached just in front of that actually transducer core material. Okay, so before that tool, in between this tool and that transducer, one horn can be attached. Okay, so this horn actually it is a its cross section. It is made in such a way that okay, so initially it starts with a higher cross section, then there is a cross section. It reduces cross. Okay, so it is made in such a way that actually it can increase the amplitude of vibration. So the term is actually horn. You can attach a horn. Yeah, actually, this ultrasonic machining process it works well when hardness is actually very high. Okay, so 40 hardness is sufficient basically. So it will become actually brittle material. Okay, so if hardness, if it is brittle material, this ultrasonic machining process does not work. Okay, so ultrasonic machining process, there is a tool which is vibrating just below the tool in that media, which is actually water-based media. So these abrasive particles are there. So when abrasive particles are hit by the tool, the lower surface of the tool, so it gains the kinetic energy and then abrasive particles hits on the workpiece surface. So in case of brittle material, so when there is tiny or abrasive particles hits on the workpiece surface, so it makes a brittle fracture on the workpiece. So hardness actually higher hardness is required. Okay, so I shall check. I think it should be 40 is fine. HRC 40 is fine. So I shall check that. So breakdown mechanism in electro discharge machining. So breakdown mechanism means in EDM process, whatever this dielectric is used, this dielectric, so when you are applying certain potential in between this tool and workpiece, okay, so this dielectric, so this electron break loose from the cathode, it moves or it attracted towards the anode or workpieces while moving through this actually media, dielectric media. Okay, so it hits on the molecules of the dielectric media, and then also there is a formation of electron and ions. Okay, so these electrons actually again hit to another molecules of the dielectric media. So there is a surge of actually electrons which is actually attracted towards the anode or workpieces. Okay, so that's why actually this it is a heating phenomena by these electrons, and there is a plasma generates. And uh, so this breakdown means actually whenever your applied voltage is greater than your breakdown voltage of your dielectric, then only actually machining occurs. Okay, so that is called actual breakdown. Um, Okay, so this HRC40, it might have done by this TS. I shall check it again. So if uh, our NPTEL office permits, then I shall uh, make it correct. पेपर है क्या? मैं ठीक है मैं कुछ असाइनमेंट जो है ना वो थोड़ा सा देखना है सर अच्छा Okay, so somebody asked the basic principle of laser beam machining process. Okay, so in that laser beam machining, so one laser source is used. Okay, so that laser source actually, you know that actually this laser is a basically photons are generated. Okay, So this photon hits the lasing material, and then so this lasing material actually it excited to the higher state, and while coming back to the lower energy state, then it generates heat. Okay. So this laser beam, whenever actually this laser beam comes out from the, uh, I have shown that actually in that PPT, that is a CO2 laser. Okay. So this energy source, whenever it is coming from the lasing medium, okay. So it generates actually huge amount of heat there, and whenever this it falls on any workpiece surface, okay. So it melts and vaporizes that material. Okay. So it is nothing but actually this energy source, this laser energy source. It is actually concentrated into a very small area, very small area. Okay, so because this huge amount of energy, it is concentrated on a small area, so that area, this it increases that means the temperature in that area, it is higher than this melting point temperature of that material, and then it melts and vaporizes that material. So advanced machine is available for machining process instead of CNC machine. Actually, this advanced machining process here we are teaching, so that syllabus already is given. So we are teaching about these non-traditional machining processes. Okay. Non-traditional machining. So basically, that CNC machine it is a traditional machining process. Okay. But in this advanced machining process, we are actually mostly concentrating on non-traditional machining processes. So that's why CNC machine it is not included. I think there is no more questions from the candidates. Okay, so if you have any questions, so we can answer through our this course through NPTEL. There is a course blog is there. From there itself, actually, we can answer. So our TS are there. So if there is any questions, I can answer there through our TA. Okay. So if you don't have any more questions, then we can close it here right now. So thank you. If you have any questions, you can directly actually in that ask through that course site. Okay. Our TS will answer the questions.